Hey everyone, this is Mayur. Welcome to MLWorks. In this video, we'll be talking about multi-index and missing data in CuDF. So before we get started with these two topics, I'll just do a small overview of CuDF, why we need it. Okay, consider you have a very large data set and you want to perform operations like group by or joining two data frames of large data frames. Okay, so when you do that using libraries like Pandas or other libraries like Polas as well, okay, it takes time because it is running on CPU based system. Now, to move away from the CPU based system or hardware constraint, what we do is we can bring that into a GPU based system and try to perform the same operations because GPU has thousands of cores available to it to perform those operations quickly. Okay, so when you perform those join operations or group by operations on a GPU, it takes much less time compared to what is done by Pandas on a CPU based system. Okay, now what we'll do is first we'll look at the GPU what we have. This is using NVIDIA-SMI. Okay, we'll look what GPU we have. Currently it has Tesla T4 and around 16 GB of VRAM it has. Okay. Next, we'll be installing CuDF using these two lines. We'll clone the repository and run the specific file. Since it is already installed, it should not take much time. Once this is done, we'll try to understand why it happens, right? Why these libraries are better, right? CuDF is better than other data analysis libraries, for instance. So this has been executed. Okay. So if you go and look into this graph, understand this graph, if you see there are join operations, okay, on a particular data set, okay, it takes around 2 seconds for CuDF to perform the join operation. The same operation for Pandas, it takes around 336 seconds. Similarly, there is a group by advanced operation which takes around 6 seconds in CuDF and it is 1700 plus seconds on DPLYR, that is another library, I guess. There is in Pandas, it takes around 280 seconds, which is like a vast difference of time if you compare, right? So this is on a 5 GB data set. Now, this is for 5 GB data. As the data set increases, these differences will go exponentially, grow exponentially. So, with that in mind, we'll move forward with respect to understanding how to perform multi-index and missing data on CuDF. Okay, first what we do is first we import the package. The key package here is import CuDF. Since we have already installed the previous cell, I'll just import those package here and we'll understand multi-index. So CuDF supports hierarchical indexing of data frames. So what does multi-indexing mean? For example, if you have around 5 columns you can use 2 columns, okay, and use those 2 columns as an index to reference the other columns. Okay, what does that even mean? For instance, here you have A, B, and 1, 2, 3, 4. Now we have only 2 columns. We can use these 2 columns as index. Okay, as index. So how it is done? First we have this array and then we turn that into tuples and then from tuples we create indexes. So we look at the index, we have a comma 1 is one index, a comma 2 is another index, b comma 3 is another index, b comma 4 is another index. Now what we are doing here is we are creating a data frame, CUDA data frame. First we have first column, the column name as first and random numbers. Similarly, second we have another 4 random numbers and we are assigning the index which we generated in the previous step. Here IDX, which is getting passed as index for this particular data frame, GDF1. Now this all these 4 into 2 8 values have this index a comma 1, which is this one. A comma 1 has this 2, a comma 2 has these 2 values, b comma 3 this, and b comma 4 this 2 values. Now similarly we are creating another index here, another data frame we are creating, and we are doing a transpose as well. and then we are passing the same index in the as we created earlier idx. We are passing it here. Sorry. So what we are doing here is we are creating a data frame, okay, and doing a transpose, and we are passing the index as columns. Okay, here it was index is passed as index, and here index is passed as columns. Let us look at that how it looks like. So here we have a comma 1, a comma 2, and first and second becomes your index. Okay, and these two things becomes this index idx, which is a comma 1 and a comma 2 and b comma 3 and b comma 4 becomes your columns. Now how to fetch values from these particular data frames. For example, here gdf1, which is nothing but this particular data frame. Okay, if you want to get specific value from this particular data frame, then we have to just do dot loc b comma 3, which is this one b comma 3, and it will fetch these two values 784297793582, which is b comma 3. Now if you do dot iloc, which is based on index, it will fetch you 10,1, that is 0101. Okay, that is 0 colon 2 is nothing but 0 and 1 excluding 2. Okay, so that's why we have these two values, first two values. If I pass 3, it will include b comma 3 as well. Okay, so this is for gdf1. Okay, similarly we can also, let me go back to this one here. I'll just add a code here and we'll do the same thing with gdf2 as well, where we'll be fetching values based on first. Let's look at what it gives, if it works or not in the first place. So it is not taking that up. Index. So since I'm giving index colon 0 1, it took for 0 a comma 1 a comma 2 b comma 3 b comma 4, all the values it has taken, and the first. Okay, if I pass 2, it will take the second row as well. But let me do something like, based on the column name, let us take a comma 2. So it has taken these two values because we are referencing this value using these two values, this tuple a comma 1 or a comma 2, b comma 3 or b comma 4. Okay, this is how we can perform multi-indexing, either row-wise or column-wise, either indexes or through column names. We can perform hierarchical indexing and fetch the values that are required. Now what we'll do is we'll look at missing values, how we can handle them here. So first we have a pandas data frame, and then we use CUDA data frame from pandas and turn that into CUDA data frame. Now here we have a column A and B, and column A has four values 0 to 3 and B has 0.1 to 0.3 with row number 2 having NA to it. So if we in CuDA what we can do is, which is similar to pandas as well, we can just do gdf.sna. It will tell you the columns value where it is NA is present. It will show in Boolean format, of course, because all these values are present, so it is false, and in this specific location it is true because there is NA is present. Similarly, here another way to look at this operation is, in column B we can go to specific column and try to understand if there is NA is present or not using dot not NA. Now, if you know how to handle missing value, we can directly fill NA with some specific value which you are aware of, and it will be fill this particular column or a particular value of a particular column into that particular value what you have passed. Now, another thing to do is, if you're not aware of what the value you want to impute in your column, what you can do is you can use some methods like fill, forward fill, or backward fill. Okay, what it will do is if there is a pattern in your data set, okay, for instance, this pattern is there 0.1, 0.2, 0.3, okay, the increasing pattern is present. You can use that as a technique to fill the missing values. Okay, so here in this case, if you do forward fill, it will take the value of 0.2 and it will pass it to NA because NA is present in row number 2. Now the same case goes to backward fill. What will happen is it will look from the bottom to up, and in this case 0.3 will be passed to this particular row. So we'll see 0.3 happening here coming up. Now, if you want to drop the column because there are a lot of values are missing in particular column, okay, then you can use access based drop. Okay, in this case, when you drop access is equal to 0, we'll look at how that particular row is completely dropped because that particular one of the column has NA present. Okay, in this case, B has an NA present in row number 2. That's why the whole row got deleted. In such case, you have to pass access is equal to 0. But when you want to drop the whole column itself, then you have to pass access is equal to 1. It will remove the whole column which has the NA value. For example, the whole column B is missing now because it has an NA value present in this particular column B. Now we have come to some conclusion, like we have, okay, so I missed this particular cell here. For example, if you want to perform some operations on your data frame which has a missing value, okay, and you don't want to include that missing value while performing some operation, then you can do something called as skip NA true. And it will skip the particular value, that is NA value, and try to perform that operation. In this case, it is sum. So if we see 0.1, 0.2 and 0.3, completely all these three added to get 0.6. So it must skip the value of NA. Okay. So with this, what I'll do is I'll try to conclude this video. We just try to understand basics of multi-indexing, how it works. So if I go back here, you can see CuDF.multi-index from tuples. So there will be other operations as well. It is from tuples. You can use list as well, or you can use other data structures as well to create multi-index and use that for creating a hierarchical indexing of your particular data frame. So why this is helpful is it will reduce the time for lookup for a particular value. That's why we need multi-index. Okay, that's the key reason for multi-index in the first place. Okay, so that is there, and then we looked at missing values, how we can impute values using forward fill, backward fill, or how to look at missing values, or if you want to skip the missing values and while creating some kind of statistical analysis, if you want to do, then you can do that as well. So all these things we have understood here. So with this, I'll conclude this video. Thank you so much.